Stanford University.
All right, everyone. Welcome back to CS193P, iPhone Application Development. This is lecture 14. We're going to be talking about touch events today, and specifically some of the applications of multi-touch on the iPhone, which is pretty interesting, unique topic to the iPhone. A couple of announcements to get us started, though. Presence 4 is due tomorrow. The usual routine is due on Tuesday night at midnight. If you have any questions, you can ask them now, or just over email on Tuesday at 10 p.m. as usual. Nothing? Okay. Yeah. So this is the last homework assignment. So if you've got some late days, you might as well use them now because you can't use them on the final project. The final project is due on the 7th, Sunday the 7th, the day before our in-class final exam period. The final exam, I don't know if we mentioned this before, it's 200 questions, multiple choice. No. We'll be doing demos of your apps. We'll be sending out an announcement about the format for that, but we're probably going to be asking you for a couple of slides to put together into a big keynote presentation. You'll have a couple minutes to just kind of click through, tell us about your app, and all that stuff. And as I mentioned before, no late days on the final. As you can see here, it's due 12 hours before you're going to be demoing it. So maybe there are some kinks you're going to work out in those 12 hours, but we'd really like you to turn in at midnight. Do you have a question?
The demos will not be televised, right?
The demos will not be televised. I believe that television cameras are typically not allowed into Stanford final exams, but I've been known to be wrong from time to time. Any other questions about the final setup? We should have. Did we send out approval emails? Okay. Approval emails are in the pipeline. The pipes are clogged. But you should be, most of them look great. You're in good shape. There's just some minor maybe notes or adjustments or things that we'd like you to be aware of. If anything, I think a lot of them are probably more ambitious than you'll be able to take on in the next few weeks, and that'll sort of work itself out as you're going. I wanted to mention some of the apps from last quarter. A few students banded together and published a little website with some of the apps. A couple of the notable ones, Air Guitar, you may have seen this up on the App Store. It's pretty sweet. The demo, I don't know if the students who wrote this, James and Edward, have a pretty sweet demo where they've got amps and they're strumming away, and it's pretty cool. There's a lot of great stuff on the site. Check it out. Maybe some ideas if you're still maybe trying to refine some of your user interface elements, that sort of stuff. And keep this in mind as the quarter comes to a close. Maybe you want to publish your app to the App Store. It's great. Strength in numbers. Roll out a big Stanford iPhone class thing because obviously there's been a lot of press. Along the same lines, one final announcement. As you all know, CS193P has been on the iTunes Store on iTunes U since April 3rd. We've been pretty consistently in the top download spot, which is pretty cool, beating out such luminaries as you see in the list here. Barack Obama down there at number 11. Yeah, for what it's worth. We've also been on the front page of iTunes. Yeah, that's kind of cool as well. I showed that to my mom. And we announced today that we have actually had 1 million lecture video downloads, which is kind of insane. So thank you to everyone who's been in the class and all the viewers online. We couldn't have done it without you. And I also wanted to take the opportunity to thank Al, who's been lecturing with me, the guest lecturers, our TAs, Troy and Paul, the Stanford Video folks, Apple folks, other Stanford people. It's been a lot of fun doing it this quarter. So yeah, 1 million and counting. So today's speakers, we've got 2 guest speakers for you today. The first one is Steve from Demiforce. He's going to be talking about the sort of design side of multi-touch and touch events in your iPhone app. So some thoughts and guidelines about touch input, specifically in games. Steve is a game author. And some different multi-touch control schemes, different options. Maybe if you're writing a game, or even if you're not writing a game, you might want to keep in mind. These are some patterns you might be interested in following. And then after Steve, we're going to have a brief little Q&A if anyone has any questions. And then Josh Schaffer from Apple is going to be talking about the nitty-gritty implementation side of touch handling, multi-touch controls in your iPhone app. So Josh is a UI kit engineer. He knows his stuff. Ask any difficult questions you may have. He will also be seen on stage at WWDC next month. So Yeah, go Josh. So I think at this point, I'm going to hand it off to Steve Demeter from Demiforce. He's going to do his thing. You're mic'd up? Yeah? Here you go.
Well, thanks a lot. Thanks to Apple and Stan for having me here. It's a huge benefit to have me here. I really appreciate it. All right, so my name is Steve Demeter. I own a company called Demiforce. My story, basically, in a nutshell, is I created a game called Trism for the App Store. It launched at the App Store back in last June. It had some success, which allowed me to really start my own company and have employees. And right now, we're working on original IP, original games, and we help companies with their games. Apple had me here, and they asked me if I could talk about multi-touch, and I figured what I could do, I could talk about thoughts and guidelines for iPhone games, and then just go over maybe 5 multi-touch examples of different, like you said, patterns and designs. So jumping right into it, thoughts and guidelines. Let me just say, first of all, that as far as games concerned, I'm a touch guy instead of a tilt guy. I think the iPhone is a casual games device. I think accelerometer games are nice. They provide a great way to kind of get a full-fledged control out of your game and have a great way to kind of not obscure the viewport at all. However, I mean, it's kind of fragile. I mean, you've got to really be delicate with these things. I think we all know of Super Monkey Ball, #1 in the App Store when it came out. But I mean, it got some flack because you couldn't really calibrate it, and you really had to be sitting down in a very unobstructed room to do this. And I figure, if you're going to be really sitting down in a very non-obstructed environment, that's probably like your living room, right? And if I'm in my living room playing a game, it's either my iPhone game or my computer game or my console game, my Xbox. And I think with that kind of competition, I'd rather have a game for on the go. Like if I'm in a subway or whatever, and I got people bumping me all over, I'd want to know I'm not going to get obstructed. So I like touch games. It's okay. That being said, I think the first thing to consider when making a game with the iPhone is that it's not a mouse cursor. You're really dealing with a big finger here. And whenever you're touching the screen, you've really got to ask yourself, what's this going to cover up, especially with multi-touch. You should never assume that all people have the same finger sizes. Even if you're making a game for kids in the kids section of the App Store, you should never assume only kids will be playing these things. All types of people play these games. We did a lot of testing. We did Trism. We found that the absolute minimum amount of real estate for one artifact to be touched is 64 pixels by 64 pixels. Any less than that, and we found that people just couldn't touch the right thing, or they're missing it, and they got frustrated and turned off the game. There are ways around this. PopCap did Bejeweled 2, which is an 8x8 grid of gems, meaning these are each 40 pixels in size by 40 pixels. And the way they did this is a little bit fuzzy logic. I really give them hats off for doing this way. What they did was, I think you all know Bejeweled 2. You're trying to touch a gem and touch another one, or swap these two. So they said, okay, if you're going to touch this one here and drag it here, you're touching this one, it might receive as this one or whatever, but chances are there's probably only one gem in this area that can generate a match. So if you touch this one or this one or this one, we're just going to use that fuzzy logic and assume you touch this one. And I've got some false positives while playing, I've got some false negatives, but in general, it works pretty well. When I did Trism, I did 2 things kind of like this to kind of aid with the touching. First of all, when I touched a Trism, I found in the beta that oftentimes I wouldn't know which one I had my finger on. So what I did was, when I released the final, was I made it so that this semi-translucent Trism would pop out, and regardless of the finger size, you'd always know what was going on beneath your finger. The second one, I don't know if you guys play Trism or not, but it works kind of like Bejeweled, but more along the lines of you slide these rows, these strips, rather than flipping them around. And what I did was, once you've established this strip and you know you want to slide this way, you can really move your finger anywhere you want to on the screen. So it's a very forgiving gameplay design. You can bring it down here, up here, and the strip is always going to be slid around the XY that you're corresponding to. So that being said, I think we can jump into the 5 types of control mechanisms that I've really found in the App Store that really work really well. Each of these games, I think, has really nailed it. First would be the slotting mechanism. This is a great example of just a control mechanism that clearly separates the control from the gameplay. It works best, I think, in tank games, because what you're doing is you're really putting a thumb on each side of the screen and just slotting up and down. In tanks here, it corresponds to each tread, both up going forward, both back going back, and then turn like this. The benefit here being you can really get a clear sense of unrestricted gameplay. The con being really, I mean, there's really only a couple kinds of games that work for this. I can think of the tank game and a few others, but really, I think unless you want to really have this kind of game, you can't really use this. Next, I think is a pretty example of leaping off on that basic core concept taking a bit further, being swivels. I think this is a really good approximation of the current generation's analog joysticks. The way a lot of guys are implementing this is that just having maybe like an input on the lower left hand and lower right hand corner, and just allowing your thumbs to kind of swivel around. So similar to sliders, you're going to have the ability to really get up and control the area without having to disrupt a lot of the gameplay. The biggest downside I've seen in this one is the fact that you're really not going to have a lot of ability to pick up your fingers up because there's no tactile feedback. I can't tell if I'm on the right corner or from the left corner of the swivel. So the way a lot of these games really get around this is by forcing your fingers to be on the gameplay area at all times. One example of this that really nailed it, I think, is iDracula. They've got just 2, I think, compasses on both corners of the screen, and it really works well. I think it was #1 back in March. And like what I said, you have this guy who just kind of like Gauntlet going around, and you walk with one swivel, and you fire with the other swivel. And because you're always needing to walk somewhere or fire somewhere, it really works really well. Another example is NG Moko's Dropship, released back, I think, in February. Similar design, but the difference here being the fact that they didn't want to have you firing necessarily all the time or moving somewhere all the time. And the way they got around this is you have these circles here and here. And you can really be anywhere you want to on the screen. If you bring your finger up and then put it down here, that's going to become the bubble here, and that'll become the focal point for wherever you want to fire your gun. Similarly, if you bring your finger up on this side of the screen and put it down here, now that'll become the fulcrum. Thirdly, just direct touch games. I really like these because this is a great example of a direct kind of input into the game, featuring nothing but just what iPhone really is. You're not trying to shoehorn any kind of last-gen control mechanism in the iPhone. You're really going for direct, pinches and zooms and swipes and that kind of thing. These games are really fundamentally new, which I think is a big part of the App Store right now. This kind of game could really have never existed before because of the fact that, the iPhone is the first mass-marketed multi-touch system out there. So chances are a game that's, featuring this kind of input done in a new kind of way is really going to get noticed by review sites and probably sell. The con, of course, being, like I said before, you're having just all kinds of fingers going on in this kind of game, here and here and here, and your game really needs to keep that in mind. And like I said, a good example of this is the game Pinch and Pop. This guy, what he did was he took this game design of kind of a match-3 concept. What you're trying to do is just pinch any 2 like colors together. And it's a non-time-based game. What you're trying to do is simply just wait for the right time which these guys touch and then just pinch together really quickly. So when you think about it, the actual interaction is happening very, very quickly, and you get your fingers off the screen as fast as you can. So it works very well for this. Fourthly, simulated D-pad games. I think the iPhone is maybe not meant for this kind of game, but I think there's a number of classic gamers out there, like myself included, who just want this kind of experience. People want ports, they want retro-style games, and we can allow them to have that. I think that, if you get a game which is like 8 buttons and, got a whole PlayStation kind of control scheme in there, it probably maybe not going to work so well, but I think if it's got if you can boil it down into maybe a couple buttons, I think it might work well. Yeah, button crowding being the main issue here. I think the two games that work really well I chose for this one is, first of all, Archibald Adventures. This was #1 back in February and then the free downloads. And as you can see here, just up, down, left, right. This is mapped over the gameplay area, and then just an action button over here, and that's all it is. Very simple game. Again, not time-based. Lets you take your time. If you make a error, if you're not doing the right thing, it's kind of forgiving. And of course, Pappy Cave. I love the Pappy games. I think this guy's got simplicity mastered. He knows how to just make a great game, and he did a D-pad game, and I love it. Just because it's even simpler. It's 3 buttons. It's just this, this, and this, or left and jump. And I find my fingers. I can't do many games like this, but I just have 3 buttons, and it works very well. So last but not least, finally, make your own. Innovation, really, it's celebrated on the iPhone. There is no one entity, or type of entities for that matter, that control the monopoly on the iPhone right now. Anybody, whether it's a student, an indie, or a venture-backed company, can make a game with a unique control scheme and really succeed. So, good luck. Any questions? Trism came about way back in the day before the SDK was released. I saw at iPhone Dev Camp 1 back in summer of '07. The first startings of just gaming on the iPhone, and I was like, I need to be here, because I wanted to really just do a game on my own and have it be played and liked by people. So I just thought of ideas all winter long. I put 4 solid months into creating an idea for a game. And I knew I wanted it to be just unique to the iPhone. Every time I got an idea for a game that was good, but not necessarily iPhone, I just threw it out. And I had probably 80 ideas before I settled on Trism. And I got the idea on February 8th. I always remember because it was 10 days before February 18th, which was GDC that year. And I was like, can I do this game from idea to demo in 10 days? And it was bad, it was nuts, but I did it. And I shopped it around at GDC, and nobody bit. It was awful, because everybody was just like, well, iPhone's too new, and we don't know what's going to happen there. Sorry. And I'm like, I can understand that. It's pretty new. But then I was like, every one of my friends liked it, and I was like, people really like this game. It's a new concept, uses the tilting. I need to really show people what this game is all about. So I put a YouTube video up on February 25th, and I was thinking I would just shop it around to 10 review sites. I emailed Mac Rumors, I emailed Unofficial Apple Weblog, I emailed this one little indie site called GameSet Watch, and GameSet Watch was the only guy that responded. Simon Carlos, really cool guy. He's like, dude, this game is awesome. I will totally interview about this. Thank you for starting your media tour with us. And I'm like, yeah, okay, whatever. But he did that, and what I didn't realize was that GameSet Watch is a subsidiary of Gamasutra, which is this huge conglomerate of game developers, and they got the interview up, and from there I went to Wired, and then New York Times got it, and there was this whole thing. And I think I had 100,000 views in the first 4 days. But yeah, that was basically it. My strategy for Trism was just it was twofold: to make a game based on unique features that really kind of push the device out there, and 2, to get it before the bell. I really wanted to get out before the gun, I think the SDK was announced on March 6th, and I did the version of this for February 25th. Because I knew just being released after would just be another game, but I wanted to really get out there first, and it had just the effect I wanted. I didn't think it would get this far, really. I certainly didn't think it'd be here right now, but it's been a fun tour, so yeah. Anybody else? No, definitely not. Yeah, I got out there. Would I have done it well if it had got out now? I think it's a good game, but I think it's I think Apple really got behind me in terms of really embracing my story and just saying, wow, this happened, so can you, I think that there is definite potential for games out there. There's always an ability for new kinds of games to be received well. But I think right now, if Trism had come out, I would probably have needed to release it at a lower price point, maybe 99 cents. Yeah.
Can you say something about price points for games and where a happy medium is?
I think it's totally cool, because right now we got this whole thing with a 3.0. right? And the transactional system, the DLC. So I think right now the top 10 games are all pretty much 99 cents. But who knows where that's going to go once you have like DLC, right? So I think that's one thing that gamers and game producers all wanted to have happen, and I think it's great it's finally happening. Yeah. DLC is downloadable content. So like if I have a Trism and it has like 3 game modes, there's a classic mode, a time mode, and a puzzle mode, where these puzzle modes are like, they're non-random patterns that you need to solve, and there's 30 of them, right? That's great, but if I wanted to have 30 more for like $1 without requiring that we download a whole new game, I couldn't do that until this summer with the 3.0 edition. And it's limitless, because now you can sell a game for 99 cents, but then get money on the back end through downloadable content. So I think it's a great idea. Yeah. All right. Well, yeah. Thank you.
Hi guys. So I'm Josh Schaffer. I'm an engineer on the UIKit team at Apple. So that's got some good foundation there. But let's talk a little bit about sort of the specifics now of with the API, how you're actually going to get in there and get the touches and work with them in your app, get them delivered to your view, see how you're going to get to them. So we can kind of skip over this. Basically, we're going to talk about why you might want to do multi-touch, but I think you probably got some good ideas of that by now. So start out with what exactly you see in your app when the user touches like this. I mean, they're going to put their finger on, and they got a big old finger there, going to slam it down on the screen. It's not quite as direct a contact as you might have had on the desktop with a mouse. The cursor is pretty small. It's pretty easy for the user to tap on exactly what they mean. But on the iPhone, they're going to be touching a much bigger spot. There's going to be a big patch, like a big contact point that they're actually touching. And from that, there's really one thing they're actually trying to touch. Really, from an app development perspective, you really just want a single point, because, I mean, you don't really know what that means. So luckily, when you're working in the UIKit level, we just end up giving you a single point. The multi-touch drivers that sit below all this, they take that contact patch and they take into account things like the device orientation and stuff like that to figure out a single point that the user was probably actually trying to touch. And most of the time, it's generally like farther above what the majority of that is. So it's probably not right in the center. So usually it's a point somewhat like that. Sure.
Do we have access to the information pre-results?
There is currently no access to the information pre-results. Just get the single point delivered to the app.
Is there any emphasis on the word currently?
There's no emphasis on the word currently.
Just checking.
Yeah, sorry. OK, so that's what we end up getting. So with that in mind, we've got a few things that we're going to cover today. Kind of a pretty shotgun thing. We're going to go through quite a few things. We'll start out talking about touch sequences, what constitutes a sequence of a touch. Then we're going to get into some of the actual touch events and objects. These are the UIKit classes that actually represent what's going on when the user's touching the screen. We'll talk about delivery, how those events get delivered to your app, how you get to see them, what form they come in, and where they go to. We'll talk a bit about single touch and then expand that to multiple touch. It's actually pretty similar. There's not a whole lot of difference. There's just a few things that you have to keep in mind when you're working with multiple touch that add a few things on top of single touch. And then we'll expand that to handling touches in multiple views. A user might be touching different things in your app, and you might want to do different things depending on where their fingers are. And then we're going to talk about how touches are routed. So we have these touch objects already, and we got to figure out where in your app you want to handle them, where your logic for touch handling needs to go, and how the touches get from UIKit to your touch handling code. And finally, if we've got some time, we'll talk about UI control objects. So UI control is a subclass of UI view, which just adds some additional higher level concepts of touch on top of the base multi-touch framework stuff. Gives you some you can write a little less code if you want to do some of the basic concepts that maybe a control would be interested in. Touch went down, touch went up in the control, touch dragged, things of that nature. So let's start out with touch sequences. Basically, what's going to happen is you're going to have an iPhone. User's going to put their finger down on the screen. That's going to be the start of a touch sequence. For the finger moving around on the screen, as long as it remains on there, it's still the same sequence. And then when the user lifts, that sequence ends. But throughout that, we just actually have a concept of a single touch sequence. So let's see how that's actually represented. So when the user first puts their finger down, we're going to get an object called a UI touch. And we create that every time a finger comes down on the screen. And it represents a single finger. So from the time that the finger goes down onto the screen till the time it's lifted, there's just one UI touch object that represents that finger. And as we deliver changes to the state of that touch, as the user moves their finger around, we'll use the same UI touch object, just one instance of it, to represent that for its lifetime. So a UI touch has a few properties that are interesting. The first is a timestamp. So the timestamp, since the UI touch represents an entire sequence, the timestamp is actually the time that that instance was last updated. So the last time the user did something to update the sequence, the last time they moved, last time they lifted their finger, the timestamp gets updated. There's a phase. So the phase tracks the different states of the touch instance itself. It maybe began, moved, stationary, ended, canceled. We'll talk about the different phases a little bit later. And then a tap count, which we increment that every time that the user taps their finger on the screen within a certain block of space and a certain period of time that we would consider a tap. It's much like a double click. There's some amount of movement that you can have, and we increment that so you can tell how many times the user tapped and do different things based on that. And then there's two other properties. There's the window and the view, and we'll get into a little bit more about how this gets determined later, but basically every touch is associated with a particular view. And for the lifetime of that touch, from the time that it goes down till it ends, it's associated with that one view, and that view is in a particular window. So you can ask the touch for what view and what window it's associated with. The question was, there's a stationary phase, and is there any ability to tweak what the stationary phase would mean and kind of filter or avoid filtering things out? But I mean, for the most part, there's really very little filtering, and most of the time, the touches are not going to be in the stationary phase. Even when you think you're holding your finger still, most of the time you're wiggling it a little bit, and you're probably going to get movement reported of 1 pixel one way or another. It's pretty hard to keep your finger stationary on the screen. Every finger, as I said, is represented by a UI touch, but, well, you've got multiple fingers, so you may get multiple UI touches if we're dealing with multi-touch, and we need a way to collect all those together. So there's another object, the UI event, which we're not quite at yet, but, well, actually, we'll skip this pretty quick. This was location in view and previous location in view. Touch obviously also has a location in the screen. You can ask it where it is in a particular view. Yeah, so now you actually want to group these together. And you'll group your touches together in a UI event. So we send touches to you both as the touch objects and as a UI event that collects all the touches that are currently active. And the UI event has a few methods on it that let you figure out where touches are on the screen, what views they're in, what windows they're in. So it also has a timestamp, much like a UI touch, and that's the last time that the event was updated, actually when it was generated. And then from there, you can ask the event for all the touches, and that'll give you all the touches that are currently active anywhere on the screen, regardless of what view or window they're in. You can ask it for the touches for a particular window and the touches for a particular view. So yeah, basically you end up with a UI event, and the UI event, it will have multiple touches, and each touch will have a view that it's in, or sorry, a window that it's in, and each one will also have a view that it's in. So if you ask the UI event for all touches, well, then it's going to return, obviously, the set of all the touches. If you ask it for the touches in a particular window, let's say we want the touches in window A, it'll return the set of touches that are currently in window A. And obviously, I'm going to go on a little more here, window B, and then we've got the touches for view. Touches for view will return all the touches in view A if we ask for view A, and then the same for B and C. So yeah, this one object lets you collect all the touches and figure out what's all going on with all of them. Now, there's currently a limit of 5 touches that can be active at any one time. It's a pretty small device. You can't really fit that many fingers on the screen at one time. If you put down more than 5, then we're actually going to end up canceling them, which we'll talk about when we get to touches canceled. But so in any case, your event will have a maximum of 5 touches right now, although there's no inherent limitation there. It's just what it is. So touch delivery. How do touches get from the UI application, which creates them, up through to your application? So there's a subclass of NSObject called UI Responder that defines a few methods that are used for delivering touches. And then there are a variety of other objects that are actually subclasses of UI Responder. And anything that's a subclass of UI Responder could then receive touches through these touch delivery methods. There's actually a defined order that they go through, and we'll talk about that a bit. But so the methods that will get called are touches began. That's called when the finger first comes down. And All of these methods have two parameters. The first is an NSSet, which contains the touches that you're being notified about. And the second is the UI event, which obviously then, as we said, will contain information about all active touches. The touches that are reported in the NSSet for these things are only the touches that are currently in the state that we're talking about. So in touches began, even if there are 5 fingers down, or sorry, 4 fingers down, if another one comes down, the only touch that will be in that set will be the one that is now currently beginning. If you want to know about the others, you can ask the event about them. But we're just reporting to you the one that's begun. So that's touches began. So the question is there an ordering kept in UI event about what order the touches came down in? And there's not. You could, since the touch objects themselves are the same across the entire duration of the touch, you could, for instance, create an NS dictionary that maps a UI touch object to a timestamp, which is the time it went down. And you could order them yourself based on that.
So I played around with this a little bit, and it says in the documentation you should never retain the UI touch objects. So how could you do that and keep them in a dictionary if you're not supposed to retain them?
Not sure where in the documentation it says that.
Never mind. It seemed like you weren't supposed to keep them around because it was changing them behind the scenes somewhere.
OK, oh, so actually, yeah, there's a distinction there between retaining it and trying to keep its state around, right? If you just retain the touch, the important thing to keep in mind there is that the state of the touch that you're retaining is going to change. So what you're saving is not the touch in its current state, but the touch itself, which may be mutated later. There's no sort of multi-threaded concerns there because there's no setters on UI touch, so you can't change the values yourself. So yeah, if you really want to keep the state of the touch as it exists right now, you actually have to copy it out into your own object and keep track of that yourself. But if you just want to map that instance of the touch that's going to exist throughout the entire thing without worrying about its current values, maybe retaining it isn't really necessary as long as you throw away your pointer to it and touches ended and touches canceled. But you can keep that around as a reference to that particular touch sequence. So yeah, there's touches began. That's the touches that are beginning. Touches moved is all the touches that are currently moving. Touches ended, all the touches that were just lifted. And then the last one, as we've been mentioning, is touches canceled. Now, this is a little odd, and often we find that people don't necessarily think that they need to implement this. It maybe hasn't been super clear. Basically, this is actually a very important member of the touch delivery method family here. Touches may not end. They may instead be canceled. So if you have your finger down on the screen and the user turns off the device, or a phone call comes in, or an alert pops up, or as I mentioned before, 6 fingers come down on the display, we won't call touches ended at that point. We'll call touches canceled. The distinction there being that you may not actually want to perform some action as a result of that. Since they're being canceled, you should probably, if you had updated something or highlighted a button, return it to its original state, but not perform the action that would have resulted had the user lifted their finger. But in that case, touches ended won't be called. So you need to make sure that if you're saving state and trying to create some state machine of touches, you implement both touches ended and touches canceled to make sure that you don't miss any. Often we see reports that, oh, we're not receiving touches ended. And usually it's touches canceled was called, and there's 2 L's in there. Often we find people touches canceled with 1 L. That's not going to get called. OK, so that's the UI responder methods that you end up getting called on your responder objects. But what are responder objects? So as I said, responder is a subclass of NS object. So UI view is a direct subclass of UI responder. But there's a few other things that you might not think, like UI view controller and UI application. And both of those things can also receive touches since they are subclasses of UI responder. And there's actually quite a few different types of views that are subclasses, obviously, of UI view. There's UI control, UI label, UI window, scroll view, image view, all these different things. All of those are also UI responders since they're subclasses of UI view. So any of those also receive these touch methods. So that's how we deliver touches to your objects. Let's talk a little bit about how this is actually going to work in practice when you've just got a single touch, the user's putting 1 finger on the screen. What's going to happen? So the user puts 1 finger down on the screen, and we're going to create a new UI touch object. Let's call it OX123. And we'll set its touch phase to began and it'll have a location. And we'll deliver it to the view that it was associated with using touches began with event. The NS set of touches began will be just this one object. So now as the user moves their finger, we're going to update the phase of this to moved, and it'll get a new location. And we'll be delivering it now with touches moved. to the same responder. It'll get the touch again. And as the user continues to drag, we'll keep sending touches moved every time that the user moves their finger. Again, just same object, still OX123, same UI touch instance, but the phase is moved and it has a new location. And then once we're done, user lifts, same object again, update the phase to ended, call that touches ended method, and the touch will be delivered there. So let's kind of do a quick demo here of how we can implement a simple application that just takes this single view here and looks for one touch and lets you drag that view around, just putting your finger down on it, direct interaction, actually using these methods here. So I've got an app that's already built here. It's just a base, mostly just the basic template. There's a few other things that we'll talk about a little bit. But we've got an application delegate. You just get that in the basic template. You know, application did finish launching. We add a subview and make the window key invisible. And we've got some cleanup code in Dialog. We've got a view controller that we're going to use to handle all of to own all of the views that we're going to move around. And that's just got a little bit of stuff, set a background color, and allow some rotation. And finally, we've got a touch image view, which is actually a subclass of UI image view. And it's got a couple properties on it. We've got a CG affine transform, which is it's a struct that represents a transformation applied to a view. So it can represent scale, rotation, and translation. And we can use that to track the finger, and we'll update its translation component as the user moves their finger around. And we'll use that to represent where the view has been moved to from its original location. And we've also got a dictionary where we're going to map the UI touch objects to their begin points. As I said before, you know, the UI touch object is updated throughout its lifetime, so it doesn't remember its begin point. If we need that later on, we have to remember it ourselves. So we'll keep a mapping from the touch objects to the points at which they began. All right, so first thing we're going to do is in our view controller, we're going to create an image here. We're going to load it out of a file. And we'll just get some image that we've got locally in our project. And then we're going to figure out how big that image is and figure out how big we want our view to be so that we can place the image on screen. And once we've got the image rect, which is the rect that we're going to use as the frame of our view, then we can create an instance of our touch image view. And we'll allocate it and initialize it with that rect that we just found and set its image to the image that we just loaded. And then we'll set its center point. Kind of hard coding this here, but you could do something more dynamic. We'll just position it in the center of the view that we're looking at so that it's smack dab in the middle of the screen, right at the beginning when we launch. And then we'll add that image view as a subview of our view controller's view, and we'll release it since we don't need a reference to it anymore. So that's about it for the view controller. Basically, we're just creating this view, not too much with the touch handling yet. For that, we're going to go over the touch image view itself. Now, you could decide to implement touch handling in a few different places. For the purposes of this, it's interesting to have the view itself handle touches. It's going to move itself around on screen. But you could do designs that worked in different places, handle touches other places if you wanted. So we're going to start out by initializing that transform that we saw earlier to CG affine transform identity, which effectively means a one-to-one mapping of everything, no rotation, no scale, no translation. Whatever frame we set on the view is the frame that it has. It's not modified at all, so that's where it's displayed. We're going to create the dictionary that we saw before. I'm just going to create a CF mutable dictionary. In this case, actually, we're not retaining the touch objects, since CF mutable dictionary lets you specify some retain release callbacks. But we could use an NS dictionary instead, which would retain them, and it would work the same way as long as we clean it all up. Have to clean it all up anyway. But. And finally, we want to set user interaction enabled on ourselves, because by default, UI image view has user interaction disabled. UI view has user interaction enabled by default. Image view just happens to have it disabled because usually image views are not interactable. So we're going to turn it back on so that we can handle touches. If we don't turn it on, then we'll never get any of the touch methods called on this view at all, and we wouldn't receive anything. So that wouldn't be so good. Oops. And yeah, now the first thing we're going to do is implement touches began. So we want to get notified when the touch begins, and we really want to store off all of the start points for the touches. since we're going to need them later. So in touches began, the only thing we really want to do is cache begin points. Now this is where I was saying that we have a little bit of hand waving and some internal things. This really just takes the points out of the UI touch with UI touch location in view self and stores it into that CF dictionary to map the touch to its begin point. Now we can look at that later if it's interesting, if you want to see it, but let's kind of gloss over it for now. So now we need to implement touches moved so that we can actually update that original transform. Sorry, not the original transform. So we can update the views transform to move it to wherever it is now relative to where the user has moved their finger. So we're going to implement touches moved. This is another kind of hand-waving part. We've got some calculations, a bit of solving a system of equations, a little more complicated than maybe is necessary, although we're going to get into some more complicated things later. But what we end up with is a CG affine transform that represents the translation of basically how far the user has moved their finger from the cached start position to the position that the current touch thinks it's at. And so we build a transform out of that, and then immediately just apply that transform to as our own transform. So a view has a property called transform, and you can apply a CG affine transform to that, which will move the view around on screen. So we're going to concatenate the incremental transform that we just calculated from the difference between the begin point and begin point and the current touch point, and we're going to concatenate that with the original transform that we saved off in when we initialized, which was the identity transform, and we'll apply that as our own transform. Sorry, go ahead.
Are these methods, are we overwriting these? So when we make the user interaction enable, there's some default behavior for touches began, touches moved?
Yeah, so by default, UIView implements all these methods, the base class does, and they do nothing. So obviously, a lot of our UIKit views actually do implement them and do real things. Excuse me, if you override one of them, you should really override all of them, because what you'll end up with is if you don't override all of them, you'll end up seeing later that whatever your superclass is, if you would end up seeing some part of a touch sequence. So it might end up getting just touches moved and ended without ever having seen a began if you only implement touches began, and that could end up confusing the super view. So if you implement any of the touch began, moved, ended, or canceled methods, you should really implement all of them. And if it's just a subclass of UIView, there's no need to call super. UIView doesn't do anything. But in other cases, if you're overriding like UI controller, UI button, you definitely want to call super on that so that you get whatever the behavior of the base class is.
Devil's advocate, when would I ever call these methods directly?
Touches began, moved, and ended. You would not want to call any of these methods directly. As we just saw a little while ago, a touch is bound to a particular view, and the UI event knows which views and windows a particular touch is bound to. So if you were to basically implement these methods and forward the touches from them onto a UIKit view, that UIKit view may turn around and ask the event for all the touches that are in itself, but the event doesn't know that any of the touches are in itself, so it'll end up getting back nil, and it may get very confused. So actually, I should clarify what I just said to Evan. You can call these methods yourself if you're calling them on your own classes, and you know for a fact that your classes don't rely on asking the event about touches that are in themselves. So if you're owning the whole thing, both the caller and the receiver, then
the rule of thumb is that you probably would rarely call these.
But generally speaking, best to let the event delivery system call these methods for you and not try and call them yourself. Right, so basically what we've done here is calculated the transform, how far the user has moved their finger, and applied that as our transform. So we're going to update the position of our view on screen based on how far the user has moved so that we track the finger. And that's about it for touches moved. Then we're going to implement touches ended so that we clean up our state, clean up our dictionary, delete any entries that are ending. And we also want to update the original transform. So now that the finger is lifted, the next time that we get a new finger down, our transform that we're going to use as the base is whatever we left with at the end, so that it doesn't end up jumping back to the center. We want to have the original transform be where we're at now, and also then remove the touches from the cache. And that's about it for that. But as I mentioned, there's also touches canceled. We really want to implement that as well. I said that you don't want to perform the same action that you perform in touches ended. You want to cancel and reset. In our case, we're going to kind of take the cheap way out and actually, perform an action. So our touches canceled will just call touches ended. But most of the time, you'd want to reset your state back to where it was when the touch began. So that's about it. Let's build this here and run it. And we're going to end up with now this view is going to be right in the middle of the screen here. And we'll be able to take our finger and, yeah, drag it around. All right. So that's single touch. Now let's talk a little bit about multiple touch, which is pretty similar, basically the same thing. But there's just a couple other things that you have to keep in mind, and one other thing you have to do to get it set up to handle multiple touch. So by default, views are single touch only. If the user puts down 2 fingers in a view and you haven't set the multiple touch flag, then one of the touches will be delivered and the other one will just get lost. It'll have its view set to nil, its window set to nil. It'll never be delivered to any view. So the property that you have to set to enable this is the multiple touch enabled property. And keep in mind, this only applies to a particular view. So you can have one view that has multiple touch enabled and another that doesn't. And you can have as many touches going on screen as you want, just only one within any view that's not multiple touch. So looking at what actually happens when the user does this now, we've got 2 separate fingers. If the user puts one finger down, they'll get touches began with event called. And we'll create one new UI touch instance, OX123. And it's going to be in phase began and have some location. And if we move it, it'll get updated to location phase moved. It'll get a new location. We'll call touches moved. Now, if the user puts down another finger, we're going to create a new UI touch instance to represent this finger. We'll call that one OXABC. And it'll get phase began. It'll have a location. And we'll call touches began. Now, as we said earlier, the only thing that's going to be reported in touches began here is the one touch that's beginning now. The other touch won't be in that set, although you could still ask the event for it and find out where it's at this point. Now, if the user moves both of them, then we're going to deliver touches moved with both of their phases updated to moved. The set on touches moved now will actually contain 2 objects, both OX123 and OXABC, because both touches are moved. Both touches have moved. We'll only deliver it once. We'll only call the touches moved method once to deliver both of them. So then if the user continues to move just one finger, but the other one stays still, the phase of the first one will go to stationary. Phase of the one that moved will stay moved. We'll call touches moved, but again, just the one that moved will will be reported. And finally, if they lift them both, both will go to phase ended, new location possibly, and we'll deliver both of them to touches ended in the same NS set. So let's expand our demo now and add support for putting 2 fingers down. We're going to let the user now have 2 fingers in this view, and they can pinch them apart to scale it or move them relative to each other to rotate it. And they can still move it around to translate it, to move it on the screen. So the first thing we have to do is enable the multiple touch enabled flag so that we can get multiple touches. And now we're going to have to make some modifications to touches began. The first thing we want to do is figure out the touches that were active before. So we're going to ask the event for the touches in view self, which is going to be all the touches that were active, including the one that's beginning now. We'll copy that just so that we can modify it. And now we're going to subtract the set of touches that are beginning at this point in this particular call, which leaves current touches with all the touches that were already active. So now we know which touches are beginning now and which touches already existed in our view. And the reason we want to do that is so that we can, now that a new touch is beginning, we want to reset our base state. So the original transform and the touch begin points in the dictionary we were keeping, we're going to basically re-baseline that to the state of the touches as they exist right now. So we'll update the original transform for the current set of touches, and we'll cache the begin points for that. And then we'll also cache the begin points for all the touches that are beginning. So now touches moved, we're going to need to add a couple of things here. Actually, we don't need to add anything to touches moved. That's already done. We're already getting this incremental transform with all of the touches. We did this at the beginning. I may have glossed over it a little bit. The incremental transform that we were calculating was actually taking all of the touches that are in the view as far as the event was concerned. So it's not just the touches that move now. Even if there was one that's stationary, that'll be included. And we'll calculate our transform based off all of them. And then in touches ended, we want to clean up our state now. We may have a little more to do since maybe not all of the touches are ending. So we're going to do something similar to what we did in touches began and figure out now how many touches are remaining. So we'll ask the event for all the touches that are in our self and then subtract out the set of touches that are ended, and that leaves us with the ones that are still down. And we'll, again, rebaseline ourselves, cache the begin points for all the remaining touches, since we're also going to update the transform now, the original transform for where we're at right now, so that when the user puts on another finger, we're going to not jump around. And I think that's all we got right here. So just build that and run. And now we can still move this guy around with one touch. Oops. Or if we put 2 fingers down, now we can pinch it to scale, as long as you don't go out of the window. We can still translate it around with 2 fingers. We can rotate it. We can scale it. And it just tracks those 2 fingers. And yeah, move that around.
Code will be on the website.
Oh, and the code will be on the website for it. Oh, there's a demo of what you just saw demoed, so that's pretty nice. All right, so multiple touches. Oh, yeah, what's up? Oh, right. The question is, are these methods that are being called, touches began, touches moved, touches ended, being called throughout the entire time that your finger's moving, and are they interrupt-based? So they're not interrupt-based. If your application is doing a lot of processing, you won't receive these. They're called from basically callbacks on the run loop. So if your application is sitting in the run loop not doing anything, then it can receive touches, touch events. If it's busy calculating something on the main thread, then your UI is going to be locked up until you return to the run loop so that we can deliver some new touches. So if you have to do a lot of intense calculation and you expect your user to be interacting during that time, you should really be doing that on a background thread so that we can keep receiving events on the main thread. All right, so we know what we're going to do with single touches and multiple touches, but now what if we've got multiple views and we want to handle touches in all of them at the same time? So as we said, we will deliver touches to multiple views simultaneously. We're going to take a look here at what that's going to look like. It's pretty much the same thing. User puts their finger down in one. We're going to create a new UI touch, phase began, give it a location, and we'll call touches began with event. User moves. We're going to call touches moved after updating the phase to moved. Now, if the user puts their finger down in another one, we'll create another UI touch. Again, phase began, new location. But now this one is bound to a different view. So if you were to ask this, if you were to ask this touch for its view, you'd get back the blue one, not the red one. And the event knows that each of these are in separate views. And now if we move both of them, we'll actually call touches moved with event twice, one on each view. And in each case, the set that we're going to be reporting as moved is only going to contain the touch for that view. So it kind of provides an ability for you to break your logic of touch handling up into separate views and keep it in separate places if you have 2 different things that the user might want to interact with. You don't have to try and remember or handle in that one touches moved method multiple things. You can separate them out. And again, if the user moves just the one, we'll get touches moved just for that one, just on the view that was moving. The other one remains stationary. We don't report that. And if they lift, we'll get touches ended in both views once for each touch. Now, you may not actually want to be able to handle touches in multiple views simultaneously. You might have some view that if the user is doing something in that, you don't want anything else going on anywhere else on the screen in any other views. So there's a property on UI view that you can use to called exclusive touch. And if you set this, then once a touch begins in an exclusive touch view, no other touch can begin in any other view anywhere on the screen. And if a finger goes down in another view, again, we just end up binding that touch to a nil view in a nil window. It's not going to be reported to anyone for the lifetime of the touch. And similarly, if you've got a touch going on somewhere else and a touch goes down in an exclusive touch view, the touch won't begin in the exclusive touch view since there's something going on in somewhere else in another view. So let's expand our demo now to have multiple views, and we can use exclusive touch to handle which ones get to do different things. At the beginning, we'll be able to pick them up and move around 2 different views simultaneously, because we're not going to set exclusive touch. But then we'll look at how that affects it once we turn that on. Actually, the only thing we really have to do here, and there's really no changes to the touch handling at the beginning here. We're just going to add a couple more views. So we'll allocate a clownfish and stones view here to represent a few more things, and we'll build and run that. Using all the same logic we already had, so now if we put down fingers in 2 of them, we can move them around. We can still put 2 fingers down in one of them and move it around or scale it or rotate it. And it can happen at the same time. So that's that. Now if we go back to our implementation of the touch image view, and where we turned on multiple touch, now we'll also turn on exclusive touch. So now if we put down a finger in both and try to move it around, we'll end up only moving one. Now, it's a little bit contrived here in the simulator because they both go down at the same time, so we just end up picking a random one. On a real device, usually it's pretty hard to get both fingers to go down in the exact same event cycle. So whichever one went down first is the one that'll get tracked, and the other one will get lost. How long is the event cycle? How long between, how close together would they have to come down for them to be delivered at the same time? And generally, at the highest rate, it's probably around a 60th of a second, because you're probably doing some screen updates, and we lock screen updates to a 60th of a second. Sorry, to 60 frames per second. But you may get them less frequently if you're doing a lot of processing or if it's not responding fast enough to get 60 in a second. Or you may get more if you're not doing enough work. Yeah, so anyway, we end up just moving one. But as you know, exclusive touch doesn't prevent us from putting 2 touches down in the same view. So we can still scale and rotate this guy. As long as both touches are in that view, they'll both get delivered. And then one final thing that we'll add is we talked briefly about tap count earlier. So let's make use of that real quick. And touches ended. Let's add one last thing. We'll iterate over the touches that are ending and check their tap count. And if one of them has a tap count greater than or equal to 2, we'll move the view that it's in to the front. So that way, if we come back over here and we're moving views around, so this guy's now behind this one and can't really see it anymore. Oops, well, sort of. If we now double tap in this one, that one comes to the front. So just making use of the tap count property. You could do other things with it, but it's kind of a one option. Oops, and I think we already got this, but let's do it again. There we go. OK, so that's multiple views. Now touch routing. So we've been talking about how touches are associated with a particular view in a certain window, but we didn't really get into how that mapping gets made. So let's take a look at the chain we go down to figure out how this happens. So we actually, we end up using what's called the UI responder chain. Am I totally in the wrong spot? Sorry, got a little ahead of myself. First, we're going to talk about touch routing. So touches get routed to a UI view, but as I mentioned briefly earlier, kind of alluded to, you have to implement all of the touch methods. That's because if you don't, we end up forwarding them down the responder chain. So there's basically a linked list of UI responders that may be able to handle touches. And we route that from the view that was touched all the way down through this full responder chain. So basically, the view that we start at is the first responder that gets to see the touch. And if that doesn't handle one of the methods, then we'll end up calling that method on the next responder, which is that view's view controller. And if that view's view controller doesn't handle it, we'll pass it up to that view's super view. And again, from that view's super view to its view controller. If that doesn't handle it, then it'll go up to that view's super view, and again, its view controller. And finally, if no view and no view controller has handled it, we'll pass it up to the UI window. And lastly, if the window doesn't handle it, we'll pass it to the UI application. Now, if UI application doesn't handle it, it just gets dropped on the floor and no one does anything with it. So if one of these had implemented the touch methods and handled that touch, well, just implemented the touch methods, then that breaks the responder chain forwarding and we stop delivering up the responder chain at that point. If you call in your touch method super touches began or super touches moved, that basically enables the responder chain at that point, and it continues to get forwarded beyond. But you probably don't really want to do that because then someone above you in the responder chain also gets a chance to handle it, and you may have already done something. But generally speaking, it looks more like this because usually only the top level view has a view controller. So usually it goes from the touched view to maybe its super view, and finally that root view's view controller, window, application. So yeah, this is where I was kind of getting at before, jumped a little ahead. How do we get to the view that gets the first crack at the touch? So we have to hit test to figure out where that goes. So the UI kit actually figures out what window the event belongs to. It figures out, just based on the point on screen, what window it's in. But then the window tries to hit test its subviews. So UI window will call hit test with event, this method, on each of its subviews. And every subview gets a chance to try and figure out if the event is within itself. So by default, hit test with event on UI view does a few things. It checks to make sure that user interaction is enabled on that view, which is why we had to enable it. If user interaction is disabled, that view won't be returned from hit test, and neither will any of its subviews. So turning off user interaction on a view actually basically blocks out an entire view hierarchy to all touches. It also checks to make sure that the view is not hidden and that its alpha is greater than 0. If its alpha is 0, it's totally invisible, transparent. We don't route touches to it. And also it makes sure that it calls the point inside with event method, which is also a public API. You can subclass this if you wanted to change the concept of what inside means. Generally, it means the touch came down within the frame of the view itself. But I mean, if you wanted to add some border around that to still route touches to that view, you could override this and adjust your hit testing yourself. And so anyway, once the view has determined that all of these things are true for itself, it then recursively hit tests all of its subviews and gives all of them a chance to see if it's in it. So it'll call hit test with event on the subview. And that will, again, run through the same thing, check to see if its user interaction is enabled and all these bits. And whatever the leaf view is that decides, hey, I'm the one that was hit, it'll return itself from hit test. And that'll just get passed all the way up back to the UI window. And the UI window says, all right, well, it was hitting me and this subview. And those are the things that end up, when we create the UI touch, getting passed into the view and window properties. So, and that's the basics of how all this stuff works. We still have time to talk about controls? Sure. OK. So there's UI control is a subclass of UI view that implements all of these methods. It implements touches began, moved, ended, and canceled, and actually provides some wrappers, a bit of higher level functionality, a simpler to use view of some of these, some more common interactions that you might be interested in. So there's a few control events that you can register for and find out when these things happen in a UI control. The first ones are when a touch goes down and when a touch goes down repeat, which is basically the tap count is greater than 1. You can register for those. You can find out when the user has dragged their finger, and you can register for a drag inside the view or outside the view. There's drag, enter, and exit, so you can find out when the user drags their finger out of your view or back in. There's touch up inside and outside, so you can find out when the user lifts their finger in it or lifts their finger when they've dragged out already. And finally, canceled, so that's going to get called if touch is canceled, gets called on the view. So the way that you would actually associate actions with these things is there's a single method that's called add target action for control events. So this is a method provided by UI control. You can call it with your own target object and an action method that you want to fire when this action occurs, and then the set of control event actions that you're interested in listening for. And so your action method can have a couple of different signatures. The first one is just no parameters. The name is unimportant. You can call it whatever you want, but basically perform action. And that'll just get called. It'll take no parameters. If you're only registering for one event, it's easy. You just implement that and perform some action in there. If you want a little more information, you can get one parameter, which would be the sender. So that'll let you find out, for instance, you could register one action on multiple controls and then find out which control actually fired it by checking the sender. That'll be the UI control object itself. And lastly, you can have a signature perform action with event, so 2 parameters. And the first one will still be the sender, and now the second one will be the UI event that caused the UI control to generate this control event. So you could then ask that for the touches that are active and find out more information if you wanted to look at some more specific things, figure out a little more about what went on. So UI control touch tracking. Let's talk about how these things, oh, right, there's actually another set of methods on top of touches began, moved, and ended. These basically mirror touches began, moved, and ended. They're pretty much the exact same thing, except they only provide a single touch. UI control by default is just a single touch object. It doesn't really handle multiple touch. So they're pretty much called directly from touches began, moved, and ended, but they'll just pass you a single touch, and it's just a convenient override point. So you don't have. So if you subclass UI control, you don't have to subclass touches began, moved, and ended, since UI control is going to be doing stuff in there. You can subclass these instead and implement your own touch tracking there. So there's basically begin tracking with touch with event, continue tracking, which is equivalent to touches moved, end tracking, which is equivalent to touches ended, and then cancel touch tracking, which is equivalent to touches canceled with event. But again, all of these only take a single touch, not the multiple touches that you could get if you did your own multi-touch processing in another view. And so this is going to be kind of a quick demo. I'm not going to write all the code. Basically, the interesting thing here is just to see, this is just a quick view, a quick demo of how a UI control sends these different things and at what time these different events fire. So we'll go over the code real quick in a second. But basically, what you end up with is you've got a UI control down here. When we put, and these up here, all these things are going to highlight when the action occurs. So if we put our finger down in UI control, touch down is going to fire. If we start moving, we're going to get drag insides going. If we move outside, we're going to get drag outsides and drag exit once. If we move back inside, we'll get drag enter and drag inside again. And you may notice that the enter and exits are firing kind of outside the bounds of the control. So UI control defines some amount of slop around itself, basically, to allow the user's finger to move a bit before we decide that we're no longer in the control. So you actually have to drag outside a little ways before it decides you're outside. And then if we lift outside, we'll get touch up outside. If we pressed and lifted inside, we'd get touch up inside. And if we multiple click, we'll get touch down repeat each time, along with touch up inside and touch down. So that's basically what they are, pretty self-explanatory, I think. So the code for this, we end up just, we've got this base thing that creates a label, kind of skip over that and highlights the label. We've got a thing that just sets up an animation to fade an alpha on that thing. That's how we get the fade effect when it's animating out. So the interesting thing is we're going to create a bunch of these labels. We'll just create them with the, sorry, that's not the interesting thing. Interesting thing is the button. We're going to create the button and give it a frame and give it a title. Then we're going to add a bunch of targets with some actions for control events. So we're going to add the object that our view controller is going to be the target of all the actions. In this case, we've got a bunch of different selectors that we're going to use that will fire when each of these actions occurred, and will register for a different series of touch events. Touch, oh, yeah, it's true. Evan just scored, I guess. I don't know. Touches cancel, touches up outside. We've got a bunch of things going on here. So we've got all these implementations of these methods now, touch down repeat, touch down inside, and they're just going to call highlight label. So there's not a whole lot to implement there, and you don't have to do a whole lot of tracking if all you care about is these particular events. You can just register them with this one method and do something in the action method yourself. Not a whole lot to it. In the case where you're trying to do some simple touch tracking, it can really simplify your code and make it easier to deal with these things. And oh, that was our UI control demo. So yeah, that's basically multi-touch. That's pretty much what you've got. So yeah, questions? The interesting thing about scroll views is there's 4 methods. Actually, there's 2 properties and 2 methods. There's a delays content touches and can cancel content touches, which decide whether or not, so when a touch goes down in a subview of a scroll view, by default, it delays delivery of that touch to the subview by a short period of time. And if the user begins scrolling in that period of time, it just doesn't deliver it at all. But after that period of time, it'll send touches began to the subview. And if the user begins scrolling after that, if can cancel content touches is yes, it's going to try and cancel the touch on the subview and then begin scrolling. If can cancel content touches is no, then it will not try to cancel the touch. It'll keep tracking in that subview and won't try to scroll. And then there's 2 methods that can give you some more fine-grained control over that per touch rather than on a global basis on the whole scroll view. Yeah, that's really what, if you need to do custom tracking in a scroll view, you really want to be using the 2 properties and the 2 methods to control delivery rather than trying to subclass the scroll view itself. It ends up getting pretty hairy, and it's hard to get it right if you try and do that. Yeah, so the question is, if you have a semi-transparent view on top of something, is that going to end up handling all the touches? So you mean, basically, you've got a sibling view, is what you want to know? Like,
so if a view is hidden, it's not actually going to receive touches, right?
If a view is hidden, that view will not receive touches. That view won't return itself from hit test, so it won't get hit tested, so a touch won't get bound to it.
And if the alpha is 0 for that view?
If the alpha is 0, it also will not get bound to it.
If the alpha is like 0.1, will it start getting?
If the alpha is 0.1, it won't. So if the alpha goes to 0.1 when a touch is already active, we don't re-hit test at every event. We run hit test once before calling touches began to figure out what view to bind to. But from then on out, a particular touch instance is bound to that view. It won't change, even if it moves out of that view or another view gets added to the view hierarchy. Yeah, does that answer the question? As long as it's, I think it's actually non-0.05. But yeah, if it's above 0.05, I think, then it can get hit tested. Or you can subclass UI view and override hit test and return anything you want. Yeah. Yeah, so the question is basically why did we set the CG affine transform? What does that get you that setting the rect directly doesn't? So for just the single finger tracking where we were moving it around, we could just have changed either the frame or the position of the view. That would have accomplished the same thing because we're just trying to move it in space. But for the rotation and the scaling, you really need to go down and set the transform so that we can rotate and scale it. For the translation, it was mostly because internally in where we were calculating the transform, we were solving a system of equations and got back one thing. It kind of simplified it to only have to set one property. There's very little benefit there to doing the transform versus the frame. In fact, yeah. Anything else?
Thank you, Josh.
OK.
For more, please visit us at stanford.edu.